Good morning. It's April 24th, and this is your daily brief in science. Here's everything you need to know. A breach at the UK Biobank has led to a temporary pause in access to its research platform as the organization pledges a full investigation and tighter security. The chief executive apologized for the incident, with 3 identified institutions having their access revoked while data access remains paused during technical safeguards and a platform upgrade to prevent de-identified data from being downloaded. The Biobank emphasizes that the data shown to researchers were de-identified and do not include personal identifiers such as names or contact details, though officials warn re-identification could be possible through factors like sex, age, birth details, socioeconomic status, lifestyle, and biological measures. The breach involves data without direct identifiers, but officials caution that advanced methods could still enable re-identification. Personal identifying information is removed before researchers access data, yet non-identifying details remain that could be used to re-identify under highly advanced techniques. Officials from M15 and lawmakers say the incident raises national security and ethical concerns about health and genetic data potentially being used to pressure organizations or influence policy. The incident is described as a breach of trust rather than a classic cyber attack, since data were provided to researchers who then listed it for sale. UK Biobank recruited participants between 2006 and 2010, aged 40 to 69. And its data have supported thousands of studies across health disciplines. The dataset underpins research in dementia, cancer, and Parkinson's, integrating biological, health, and lifestyle information, including de-identified genome sequences, brain scans, blood samples, and diagnostic records. Geopolitically, the appearance of these data on a Chinese platform is expected to sharpen UK-China discussions on tech and data security policy. A new science study suggests giant Cretaceous octopuses, potentially reaching about 62 feet in length, may have been apex predators in warm, shallow seas based on exceptionally preserved jaw fossils. Researchers paired a novel method called digital fossil mining with grinding tomography and AI to produce high-resolution 3D jaw models that enrich the paleoecological picture. Wear patterns on the beaks indicate larger individuals processed hard prey more extensively, with signs of blunting, chips, and possible lateralized feeding behavior. However, independent experts caution that the evidence is intriguing but not definitive, and they call for further research before firm conclusions about diet or hunting strategies. Uncertainties remain about body shape, fin size, swimming speed, and diet since no fossil record shows stomach contents. The paper notes that additional octopus fossils from different regions are needed to fully delineate their place in marine ecosystems. Paleontologists acknowledge the findings are provisional and will require time to fully understand these giants' ecology and behavior. The team plans to expand digital fossil mining to uncover soft-bodied organisms and broaden understanding of ancient ecosystems. Other experts not involved in the study emphasize the need for more fossil discoveries to clarify the octopus's role in ancient food webs. Scholars stress that conclusions are limited to jaws, with size estimates potentially varying and stomach contents remaining unknown. Because ancient octopods differ from modern forms, firm conclusions about their ecological roles remain cautious and provisional. A new tool aims to measure breast cancer risk at the cellular level using MechanoAge. MechanoAge, developed by City of Hope and UC Berkeley, analyzes the mechanical aging of single breast epithelial cells to assess individual risk. Many women lack known genetic risk even as cancer incidence rises, and current density-based or population models can misclassify risk, leading to over- or under-screening. The Lancet eBiomedicine paper describes a machine learning pipeline that distinguishes mechanical properties of cells and assigns a numerical risk score, noting there is no widely available non-genetic test for identifying higher-risk women yet. MechanoAge rests on a scalable, affordable setup that uses simple electronics and computer chips, avoiding expensive imaging technologies used in earlier methods. The device uses mechano-node pore sensing with a straightforward hardware design to capture mechanical cell properties and enable scalable risk assessment without costly imaging equipment. Researchers say MechanoAge could be highly scalable and affordable, making non-genetic risk assessment more accessible and supporting earlier personalized clinician discussions. From the researcher's view, MechanoAge provides cell-derived risk information for patients to discuss with doctors, with scalability grounded in its simple hardware. Funding comes from NIH and the American Cancer Society, with no competing interests reported. Related patent activity points to groundwork for commercialization. Validation across diverse cohorts shows accuracy in distinguishing high-risk profiles and aligning risk scores with genetic susceptibility and clinical diagnoses, including high-risk individuals with known mutations and distinguishing them from healthy controls and those with non-genetic risk factors. Looking ahead, MechanoAge could enable earlier, more precise cellular-level breast cancer risk detection, broader accessibility, and potential applications to other age-related diseases. The platform monitors cell translocation and real-time data on size, shape, deformability, and recovery dynamics to yield an integrated health and resilience index. The CMS and FDA are launching RAPID, a pathway to speed Medicare coverage for FDA-designated breakthrough medical devices by coordinating early with manufacturers during the review process. The goal is national Medicare coverage and payment as soon as 2 months after FDA market authorization, a sharp contrast to the current pace of about a year. After FDA approval, a 30-day public comment period will follow before Medicare decisions are finalized, with the aim of delivering national coverage determinations for breakthrough devices within months rather than years. Industry reaction is cautiously optimistic. AdvaMed says this could improve access but calls for clear timelines, accountability, and effective implementation to ensure patient benefits. Cardiology remains a major focus, accounting for the largest share of devices in the Breakthrough Devices program, totaling nearly 250. Medicare Deputy Administrator John Brooks says RAPID will clarify the targets manufacturers must hit to obtain coverage, aligning investment timelines with regulatory expectations. CMS emphasizes this is a coordinated effort to streamline access while maintaining evidence standards, and notes, the transitional coverage for emerging technologies pathway will be paused to focus on RAPID. The public can comment on the proposed procedural notice after its Federal Register publication, with a 60-day window, and the scope targets certain FDA-designated Class II and Class III breakthrough devices for Medicare beneficiaries. The initiative builds on the FDA Breakthrough Devices program, aiming to align evidence collection with Medicare coverage needs by engaging CMS experts early and identifying clinically meaningful outcomes for beneficiaries. RAPID addresses long-standing industry complaints that Medicare reimbursement decisions for breakthrough devices take too long, and seeks to shorten the timeline from FDA authorization to coverage. Historically, it can take about 5 years from FDA authorization to Medicare and commercial coverage, highlighting RAPID's potential to expand patient access. A Florida State University project is using an underwater autonomous vehicle guided by divers to test water quality at spring sources and map cave systems, aiming to link geology and environmental factors to water quality and quantity. The effort brings together the University of South Florida, Woodville Karst Plain Project Cave Diving Team, and Sunfish to train and deploy the UAV for cave mapping and water sampling. Florida hosts more than 1,000 springs, making mapping these systems crucial as water levels fall, flow decreases, and water quality concerns rise. Led by Ming Ye, a longtime FSU faculty member known for hydrogeology and computational modeling, the project emphasizes interdisciplinary work and honors. Ye's work has secured over $2.5 million in Florida DEP funding to study groundwater sources in the Wakulla Springs Basin and to map its underwater cave network. The grant supports mapping Wakulla Springs Basin to improve understanding of Florida's water supply. Wakulla Springs serves as a critical groundwater exit point for the Floridan aquifer, supplying drinking water to nearly 10 million people, and its cave network spans about 25 miles. In 2024, Wakulla Springs was designated an International Geological Heritage Site, highlighting its scientific and cultural significance. Background: Wakulla's basin is Florida's largest, with extensive cave systems and a major role in regional groundwater and ecosystems. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.